I welcome you all in today's video. Today we're going to discuss, rather we're going to talk about different types of numbers, because in mathematics we really need to understand these types of numbers so that we lay a firm foundation. Types of numbers is the first topic when we look at the syllabus for the Form 1s. It's the first topic where we're going to understand these different types of numbers. My name is John Manda. Alright, so without further ado, in this video we're going to be understanding the different classification of numbers, which is fundamental to mathematics, from simple counting numbers to complex irrational values. And each type serves a unique purpose in mathematics specifically. Alright, so let's look at the first type of number we're going to look at, or type of numbers we're going to look at rather. So the first two types of numbers, I call them building blocks of mathematics, which is natural numbers and whole numbers. Okay, so natural numbers, we're talking about counting numbers we use every day, starting from 1 counting up to infinity upwards. Okay, so natural numbers are counting numbers. If we're counting a bunch of things, we use these numbers excuse, and they always start from 1. I've given an example there: 1, 2, 3, 4, and 5, going so on. Okay, so these are the first numbers we learn as children, used for counting objects and ordering items. So those are called natural numbers. And we have another type of numbers which we call whole numbers. Okay, so whole numbers, most of the people, they confuse whole numbers and natural numbers. Okay, we know that natural numbers with one important addition is 0. This set includes all counting numbers plus the concept of nothing, which is a 0. Okay, so the main difference between natural numbers and whole numbers, with natural numbers, we're just starting from 1. No wonder we use them for counting. But whole numbers, we begin with 0. Okay, so 0 going upwards. Okay, so 0 is crucial for representing absence and serves as the foundation for our number system. Okay, it shows nothing. Okay, so those numbers which start with, from 0 going upwards are called whole numbers. Okay, I hope we get the difference between natural numbers and whole numbers. I paired these two so that we also get the difference, because most students misquote these two types of numbers. All right, now we can talk of expanding the number line, okay, which in simple terms we call integers. Okay, now what are integers? So integers include all numbers and their negative counterparts, okay, extending infinitely in both direction. Okay, so if you look at a number line on your right side, on your right hand side, we have positive numbers starting from 0. Okay, so no wonder we're saying it is including whole numbers, not natural numbers, because there's a 0 there, and the 0 demarcates the negative and the positive numbers. So positive numbers are found on the right hand side of the number line, then negative numbers are found on the left hand side of the number line. Okay, and we have that example which is given there, which is -1, -2, -1, then we have a 0. Then from 0 down, we go to positive numbers, 1, 2, 3, going so on. Okay, so there you can see that 0 has no sign. It's neither positive nor negative. It's just trying to demarcate the negative numbers and the positive numbers. Okay, so these numbers are used for representing temperature, evaluation, dates, and many real world situations involving opposites. Okay, so like you might find that temperature might be negative something or positive something. Okay, or positive 20 degrees, negative 10 degrees Celsius. Okay, so those now are integers, numbers with negatives. Okay, all right. Then apart from that, we have divisibility patterns, even and odd numbers. Okay, even and odd numbers. I have made sure to pair these types of numbers in a group that will help you to understand them. Okay, so now what are even numbers? So even numbers, these are numbers perfectly divisible by 2 with no remainder. Those are even numbers. Even numbers are numbers where 2 can go into without leaving a remainder and always end in like for example, there we have 0, 2, 4, 6, and 8. Why? Someone might ask it, why are we adding 0 there? Can 2 go into 0? Yes, 2 can go into 0. 2 divided by 0 divided by 2, it's 0. Okay, so that is a very important concept you also need to understand. So no wonder I've included a 0 there. So 0, 2, 4, 6, 8, 10, 12, 14, 16, as so on and so forth. So those are even numbers, okay? And take note of the 0 I've included. Now, and I've tried to highlight that saying 0 is considered even because it is divisible by 2. 0 divided by 2 is 0. So we need to take that into consideration also. Then odd numbers. So odd numbers, these are numbers that leave a remainder or 1 when divided by 2. Okay, so 1 there is also included. Okay, like if we talk of bases, you understand this perfectly well, why we also include 1 there, because we know that 2 cannot go into 1. Okay, so 2 into, if we're talking of bases, 2 into 1, specifically in base 2. Okay, 2 into 1, that is your remainder 1. You get that? So that is why I've also included a 1 there. So 1, 3, 5, 7, or 9. You can see that always in these numbers, when we divide these numbers by 2, that always will leave in a remainder. Take note. Okay? So we also have negatives there, like -3, -1. They're also odd numbers. Okay? Let's continue. All right, now, special categories, prime and composite numbers, okay? So, someone might misquote prime numbers with odd numbers, okay? Odd numbers, okay? Someone might misquote odd numbers and prime numbers. So, get the difference, please. So, prime numbers, numbers greater than 1 that have exactly 2 factors, 1 and themselves. They are the building blocks of all other numbers. Okay, let's understand that. So, prime numbers or prime factors, these are numbers when we divide, or they only have 2 factors, which is 1 and the number itself. For example, 2. The only numbers that can go into 2, it's 1 and 2 itself. Okay, then 3. The only numbers that can go into 3, it's 1 and 3 itself. Same applies to 5. The only numbers that can go into 5 are 1 and 5 itself, okay, without leaving a remainder, okay. Same applies to 11 and 13, okay. So those numbers where they're only having 2 factors, 1 and the number itself, those are known as prime numbers. It's different from odd numbers. We've said that odd numbers, these are numbers that when divided by 2, they will leave a remainder. Okay? Exactly. So that's a difference. Okay. So but prime numbers, these are numbers that only have 2 factors, which is 1 and the number itself. Okay. So the fun thing is that 2 is the only even prime number. Okay, 2 is the only even prime number. Mind you, 2 is an even number because we said that even numbers, these are numbers when we divide by 2, they're not leaving a remainder. Okay, so 2 is an even number. It is also a prime number. How is it qualifying being a prime number? Because when we divide, or when we look at the factors of 2, the numbers that can go into 2, it's 1 and 2. And we've said prime numbers only have 2 factors, 1 and the number itself. So 2 qualifies to be a prime number 2. Okay, so that is a fun fact. Okay, the fun fact is that 2 is the only even prime number. Okay, now composite numbers. So numbers greater than 1 that have more than 2 factors, they can be broken down into smaller prime factors. For example, 4. You can see that the numbers that can go into 4 are 1, 2, and 4 itself. So it is having more than 2 factors. Okay, more than 2 factors. Mind you, a factor is a number that goes in a given number without leaving a remainder. That's a factor. We also need to understand that. Okay, so 4 is having more than 2 factors, which is 1, 2, and 4 itself. These 3 numbers can go into 4. Same applies to 6. Okay, 6 is also having more than 2 factors, which is 1, 2, 3, and 6 itself. Okay, same applies to 8, 9, and 10. They're having more than more than 2 factors. Okay, now one thing that we really need to take note is that 1 is neither prime nor composite. It is in a category of its own. 1 can go in all the numbers without leaving a remainder. Okay, so it is neither prime nor composite. Okay, 1 can go in all the numbers without leaving a remainder. We need to take note of that. It's very, very important. All right, now let's talk of now fractions and decimals, which we simply call rational numbers. So what's the definition of rational numbers? So we say rational numbers, or a rational number, this is any number that can be expressed as a fraction where both a and b are integers. Okay, we'll talk about in fact we've talked about integers, the negatives, okay, or those numbers found on the number line. Okay, so that is how we define rational numbers. Okay, we're talking about now fractions, okay, or decimals in short. Okay, now the key properties. So the key properties is that these numbers, they include all integers. Okay, for example, we have 3, which is 3 over 1. Okay, terminating decimals, or when we divide, that is what we're going to have, or when we talk of 1 over 4. 1 over 4 is basically 0.25. So a fraction can be expressed as a decimal again, because we're talking about division. Okay, so we can divide that. Once we divide a fraction, we're going to have now a decimal number. Okay, no wonder I grouped these to say fractions and decimals. Excuse. So for example, we have 1 over 2, which is basically 0.25. Okay, then we also have negative 3 over 4. We have 5, negative 2, we have 0.66. So these are just examples. Okay, we can find that these numbers can always be written as a fraction of 2 integers. Okay, so that is about fractions and decimals. All right. Now we have something beyond fractions, which we now talk of irrational numbers. Okay, so these numbers, they cannot be written as fractions. Okay, mind you, irrational numbers have decimals represented that never terminate and never repeat a pattern. Okay, that is one thing that you really need to understand. Common examples, we have the square root of 2, which is 1.414. Okay, we also have pi, which is 3.142. We also have the square root of 3, which is 1.73. Okay, so those are some examples of irrational numbers. Okay, so these numbers are essential in geometry, trigonometry, and describe many natural phenomena. Okay, so we really need to understand these types of numbers carefully, because these are the numbers which we're going to be talking of, like if we're looking at geometry, trigonometry. Okay, we're going to be classifying or finding out these numbers. Now it is very essential to first understand these types of numbers. All right, let's look at some worked examples where we need to classify some numbers. All right, now I've tried to simplify things for you here. So once you want to classify a number, the first thing you need to do is identify each number. Okay, you first identify each number. Okay, we need to examine each number individually and consider all possible classifications. Why? Because a number can be categorized or can be in other categories. Okay, so it's not just if it's an even number, then it's forever an even number. Okay, that is wrong. Okay, if for example, if we look at 2 is an even number. Again, 2 is a prime number. Okay, so we need to examine each number individually and consider all possible classification. Then number 2, what we need to do is apply definitions of those categories of numbers. Okay, we use the properties we've learned to determine which categories each number belongs to. That is the second thing that you need to do. Then number 3, or the third thing that we need to do is multiply classifications or multiple classifications. We need to find out this multiple classification. Okay, remember, a single number can belong to multiple categories simultaneously. Okay, for example, the number 2. So 2 is an integer, even number, and rational number. Okay, so looking at those 3 steps I've given you, you can see that we can qualify 2, -2, to be an integer, an even number, and a rational number. Okay, then 0 is a whole number and an even number. Okay, then 3 is a natural number, odd number, prime number, and an integer. Okay, then 1/3 is a rational number because it can be expressed again as 0.5. Okay, mind you, 1 divided by 2 is 0.5. Okay, then the square root of 2, is irrational. Okay, so these are some concepts that will help you to classify these different numbers. Okay, now we look at now a quick reference guide. Okay, so to start with the basics. Okay, it is a natural number, a whole number, and an integer. Okay, when, now how? So check divisibility. Okay, so the first thing that we start with, okay, to start with the basics, okay, you first check if it is a natural number, a whole number, or an integer. Take note. Okay, the first thing that you're supposed to do to classify a number, check if it is a natural number, a whole number, or an integer. Okay, then number 2, check divisibility. Is it even or odd, prime or composite? That's the second thing you need to do. The third thing, consider now fractions. Okay, can it be expressed as a fraction? If yes, then it is rational. Okay, then lastly, everything else is rational. Okay, if it cannot be written as a fraction, it is irrational, but still a real number. So these are some of the things that we need to look at to be classifying these numbers without a problem. Thank you very much for your time. In the next video, we are going to now look at how we need to factor out these numbers, looking at factors and multiples. Okay, thank you very much. Okay, we continue. Now we're going to look at factors and multiples. Well, we're going to understand the building blocks of numbers and how they relate to each other, which is also very essential. All right. Now, after understanding what factors and multiples are, the first thing that you need to learn is to identify factors and also identify multiples. And also you apply this concept in real life because it is applicable to everyday life. Okay, so those are some of the learning outcomes. Okay, now what are factors? Okay, what are factors? So a factor is a number that divides another number exactly with no remainder left over. Okay, let me repeat that. A factor is a number that divides another number exactly with no remainder left over. Okay, or in simple terms, let me simplify it for you. So a factor, this is a number that can go into a given number without leaving a remainder. This is a number that can go into a given number without leaving a remainder. For example, if I have 2, 2 can go into 2. So 2 is a factor of 2. Okay? Or the example that has been given there, which is 12. You can say 1 can go into 12, 2 can go into 12, 3 can go into 12, 4 can go into 12, 6 can go into 12, and 12 can go into 12. So those numbers I've highlighted are the factors of 12 because those are the numbers that can go into 12 without leaving a remainder. Okay, all right. Now, what about multiples now? What are multiples? So, a multiple is a product of a given number, okay, and any other number, which might be an integer, okay. Multiples extend infinitely in predictable patterns, okay. Now, what do we mean there? Okay, so in simple terms, a multiple, this is where a given number can go into without leaving a remainder. Okay, this is where a given number can go into without leaving a remainder. For example, the multiples of 5. So 5 is the given number. So we find out the numbers where that given number can go into. Okay, so 5 can go into 5. 5 can go into 10. 5 can go into 15. 5 can go into 20. 5 can go into 25. 5 can also go into 30. Okay, so those numbers where 5 is going into is now a multiple. Okay, so in simple terms, I've said multiples, these are numbers where a given number can go into without leaving a remainder. That given number where it is going into or where it is divisible evenly without leaving a remainder. Okay, those are known as multiples. Okay, now factors versus multiples. Let's compare these looking at their differences. So factors, numbers that divide into another number. Okay, numbers that divide into another number. Wow, multiples, numbers created by multiplying in simple terms. I'll give you an example shortly. Then difference number 2, limited set or finity. So factors, they have a limit, they end at a certain point, okay, while multiples, the infinity, unlimited set, they can just keep on going. For example, if we talk of the multiples of 2, so we're talking about numbers where 2 can go into without leaving a remainder. So we just simply start adding. What is 2 plus 2? That's a 4. 4 plus 2, which is a 6. 6 plus 2, which is 8. 8 plus 2, which is 10. So we can just be going. We'll never end. Okay, no wonder I've said that to say the infinity, they do not end. Then the third difference was saying always smaller or equal to the original number. Okay, always smaller or equal to the original number. While for multiples, always larger or even or equal to the original number. Take note of that. Then now examples of factors of 20. So we have 1, 2, 4, 5, 10, and 20. So there you can see that those numbers, in short, this is one secret. Factors always end with the actual number. Okay, with that same number. For example, say factors of 20. So they will end at 20 because 20 is the last number which will go into 20. Okay, but for multiples, they will start with the actual number. That's a secret. Okay, the multiples will start with the actual number. For example, multiples of 4. So we're starting with 4 because 4 is the given number. We're looking at the factors, the multiples of 4. So 4 can go into 4 one time. 4 can go into 8 2 times. 4 can go into 12 3 times. You get that? Okay, so that is how it is. That's the secret. Okay, so for multiples do not end. Okay, thank you very much. Okay, we continue now. So after understanding what factors are and what multiples are, we can now look at how we find the highest common factor and the lowest common multiple. Okay, so this helps us to discover powerful mathematical tools that simplify problems and given hidden patterns in everyday life. Okay, so it is very important to also understand this key concept. All right, now After understanding or after knowing how to find the highest common factor and the lowest common multiple, you need now to know how to find these and solve real life problems. Like, you apply now this to the real world, okay, this concept. All right, now without further ado, let's start with the highest common factor, understanding the highest common factor. So now, what is the highest common factor? Okay, so the highest common factor is the largest number that divides evenly into two or more numbers without leaving a remainder. Okay, so we are now talking about the largest number or the common number. Okay, so we, in simple terms, think of it as finding the biggest shared piece between numbers, perfect for dividing items into two equal groups or simplifying fractions. Okay, that is what the highest common factor is. All right, so here now, when we're looking at finding the highest common factor, we can use two different methods, okay, which is the listing method, where you list all factors of each number, then identify the largest factor that appears in both lists. Okay, so this is quick for smaller numbers. Okay, then we have the prime factorization method, okay, where we break each number into prime factors, then multiply the lowest powers of common prime prime numbers together. Okay, so this is just efficient and systematic for larger numbers. All right, let's look at these examples. Okay, so now we have finding the highest common factor. Okay, so we can either use the prime factorization method or the listing method. So the simplest is the listing method, because we're talking of smaller numbers like 18 and 24. These are just smaller numbers. Okay, so the first thing, you first list the factors or the numbers that can go into 18 without leaving a remainder. So you know that the numbers that can go into 18 without leaving a remainder are, we have 2, 3, 6, 9, and 18 itself. Okay, so these numbers, they can go into 18 without leaving a remainder, which is 2, 3, 6, 9, and 18. Then the numbers that can go into 24 without leaving a remainder are 2, 3, 4, 6, 8, 12, and 24 itself. So there, the largest common number that we have is 6. So 6 becomes the highest common factor. So that is the listing method. You can use the simplest rather than the factorization method, which I've used in my presentation. Okay, so you can be going with the listing method, whereby you just find out the numbers that can go into 18 without leaving a remainder, and the numbers that can go into 24 without leaving a remainder. Then look for the largest number that is appearing in both numbers. Okay. All right, now let's look at the lowest common multiple. Okay, so what is the lowest common multiple? So the lowest common multiple is the smallest number that is a simple or the multiple of two or more numbers. Okay, it is essential for finding common denominators. Okay, synchronizing schedules and solving timing problems. Okay, think of the lowest common multiple as discovering when patterns align, like when two events will occur together again. Okay, that is what happens, or that is what it is when we're talking about the lowest common multiple. Okay, so we also, again, we can also use two methods, just like finding the highest common factor. So even though we can use the listing method, where we list the multiples, then find out the lowest number which is appearing in both lists. Or we use the prime factorization, where we express each number as a prime factor, then take the highest powers of the all prime present, then multiply them together. This is just more efficient and complex calculations. Okay, all right, let's look at that example we have there. Okay, so we need to find the lowest common factor or multiple, sorry, the lowest common multiple of 6 and 8. Okay, so we're talking now, since we've understood to say a multiple, this is where a given number can go into without leaving a remainder. So we first list the numbers where 6 can go into. So 6 can go into 6 itself, it can go into 12, it can go into 18, it can also go into 24, into 30, and 36. We can end there. Then 8 can go into 8 itself, 8 can go into 16, 8 can go into 24, 8 can go into 30, 8 can go into 38. We can also end there because these numbers are infinity. Okay, so now we find out which one is the lowest number which is appearing in both lists. I'm using the listing method, not the prime factorization. So you can see that 24 is appearing in the two lists. Okay, so 24 is the lowest common multiple of 6 and 8. That is what we do. All right, now how do we apply this in our real life situation? Okay, so here in this example I've tried to use the traffic light problem. Okay, so the problem is that two traffic lights flash at different intervals, one every 30 seconds and another every 45 seconds. When will they flash together again? Okay, so here now it's same thing. We just find out the multiples, okay, not the factors, because this now we're talking about the multiples because we're looking at the chance where they're going to align at the same point. Okay, so we're going to find the multiples of 30 and the multiples of 45. Okay, so you know that the multiples of 30, okay, or the numbers where 30 can go into. Okay, so we have 30 can go into 30, 30 can go into 60, 30 can go into 90. Okay, and so on. They won't end. Okay, then we also have 45. 45 can go into 90. Since 90 is among the multiples of 30 and 45, which means 90 is the answer. Okay, so which means these flashlights, they'll flash together every after 90 seconds. They flash together after 90 seconds. That's how you apply this now into real life situations. All right, now the key takeaways we need to know is we find the highest common factor, which is just finding the largest shared factor. Okay, used for dividing, grouping and simplifying factors. Okay, then the lowest common multiple finds the smallest common multiple, perfect for scheduling, synchronizing events and adding fractions. Okay, then the two reliable methods for each, we can use either the listing or the prime factorization, will always arrive at the same